in this lesson. So here we're going to be looking at the nested loops. So nested loops are loops that are contained within another loop. In programming, they allow for performing multiple iterations over a sequential of elements in a structured way. Right. So on most occasion, when nested loop often results to this order of n square complexity. For instance, if you have a nested loop where both the outer and the inner loop iterate n times, the number of operations grows upon proportionally to n times n, which equals to n square. So this is what gives us the algorithm quadratic time. So let me explain this so that you guys can understand it practically. Now, I'll go to my Visual Studio, right? So this is my app.py. Remember that we've already created this on our previous videos when we were doing our practicals. Now, this is nested loop. Let me explain what I mean. Let's assume that we have a variable n that holds an a that holds a list, right? So this list have items which are integers inside, like collection of these integers, right? So I have this. Let me use four. Let me use four integers. So now the next thing I will do is I have a variable x to get the length of n, right? So let me look through now for I in range of starting from 0 down to the number of times this I will iterate, which we is of x. So if you check, so x takes the total number of items in this list, which we have total number of 1, 2, 3, 4, right? So automatically this first loop will loop four times, right? So when I, it means that on the first loop here, it becomes um, I when I is equal to 0, because I is starting at 0, right? Then n of I is equal to the n of I now, which is the this n is one that holds this list. So if you pass I, which is 0, to the n here, it will fetch out the value located in what? In the 0, which will give us 3, right? So when I is equals to 0, then n minus I is equals to 3, right? So let me do it four times, because the computer will definitely iterate four times, because the total number of items we have here is four, so it will go four times. So when I becomes 1, right? So n of I will fetch out 5. When I becomes 2, n of I will fetch out 35. When I becomes 3, n of I will fetch out 77, right? So now, but this is not the nested loop, right? This is just a single loop. Now let's do the nested. Remember that we said if you have a nested loop where both the outer and inner loop iterate n times, that is what we want to do now. So the number of operations goes proportionally to n times n, which is equal to n squared. So now this is n, right? We have done n. This is for n. So now the other n, which is, let's use another variable name. You can use any variable name of your choice. So let's use O for O in range of starting from 0, right? Starting from 0 again down to x, right? So now this now, it means that the second inner code that means that when I is equal to 0, right, then this is this, right? So automatically this outer loop, because this is the outer loop and this is the inner loop, so this outer loop will grow four times, right? Because the inner loop is looping four times, right? uh, so that means the for each of the outer loop, right, run the inner loop four times. So it means that what we have now, we now have when I is equal to 0, when I is equal to 0, four times like this, right? Then when I is equal to 0, then j is equal to 0, right? Then sorry, it's not j, it's o, it's not j. Then o is equal to 0, o O is equal to 1, then O is equal to 2, then O is equal to 3, right? So 0, 1, 2, 3, right? 0, 1, 2, 3. So you can see what happens. You can see that the number of sides increases. So it means there's n times n, which is equal to n squared, right? You can see what happens here because we have this inner loop here. So what the inner loop would do does is that it runs 4 times for each of the outer loop. So now we will do the same thing. Watch for when I becomes 1 now, right? When I becomes 1, so it will now do the same thing for, it will now run 4 times. You can see it will now run 4 times. So when I becomes 1, 1, 1, 1, 1, right? So 1, 1, 1, 1. So here we now have here will be 5, here will be 5, here will be 5, here will be 5, then this 0, 1, 2, 3. So here will now be still be 0, 1, 2, oh, will be 0, 1, 2, 3. That is how it keeps on going. So in total we have in total now we now have like 4 times 4, which will give you 16. So if we are doing the calculation here, remember if it's just one inner loop to be n equal 4, right? So it's iterating 4 times. So since there's an inner loop, it will now be n square, right? Which will give us 16 times. Which will give us 16 times. Because if we count this, right, it's now be 1, 2, 3, 4, 5, 6, 7, 8, right? This is for 2. Then when I is 2, right, add another 4 iterations, which will give you 12. Then when I is 3, another 4 iterations, which will give you 16. So that's why this is a typical example, right? So this is a typical example of the quadratic time complexity, right? Which is has to do with the big O order of n square, right? So now this is how it works, right? You can see that when if it's just one loop, right, n will be 4. But since there's an outer loop and there's an inner loop, so it becomes n times n, right? So it becomes n square. It becomes n squared. So that means for every loop, for every outer loop, it will loop 4 times. So that means if you count it, you can see the example we did, breaking it down one by one. If you count it, give you n to be n, it will now be equal to 16. N will be equal to 16. So if we have 5 elements here, it will now be n will be equal to what? It will now be 5 times 5. So n will now be equal to 25 iterations. So that is how it works, right? So that's why it's a quadratic time complexity. So it's very simple. So now let's do this practically and see how it works. Now for I in range of this, for O is range of this. So let's print and see what happens, right? So print, let's use a format so that we can actually get the value format, right? So this is a string. So let's print I, then let's just use this pattern we use here. Let's use this pattern so that we count the iterations. So I'll pass it here like this, right? So when I is equal to, I'll put I here, then n of I is equal to, I'll put n of I here, n of I, right? Then O, this is our O, is equal to, so our O will be equal to O here. Let's use then n of O will be n of O will be equal to n of O, right? So now let's run this. We'll go to our terminal. So pi app.py. So now let's count how many times that trace, right? So now when I is 0, then n of I is 3, right? You can see this is just what I've written here. And then O is this. So let's count the number of iterations. Remember that we have 4, so it's supposed to give us 16 iterations, which is n squared, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's go down. 13, 14, 15, 16. Now you can see how the quadratic time complexity works, right? You can see that it's an n square because it's running 16 iterations, right? It's just what we solve here. That's what gives us here. Now let's solve one example before we look at them. In the next video, we're going to solve more examples that has to do with nested loop. So now let's look at this simple bubble sort, right? So what this bubble sort does is it compares the adjacent value items in the list, right? So if you are going through the ascending order, if the smaller number, if the first index, the value in the first index is greater than the value in the second index, then swap, right? That's how it keeps on doing it adjacent. Okay, now given these three items here in this list, right? You can see in the first one, in the first index, this index starts with index 0, 1, and 2. Now, if 3 is greater than 1, right, then 1 should come to three's position and 3 goes to one's position, right? So in the next part, in the next move, you won't compare 1 anymore. You have to go plus 1 down to the next place here because it starts at 0, right? So it has to come to the next place and then compare. If 3 is greater than 2, right, swap. So since 3 is greater than 2, it swaps and then it gets sorted, right? So this is just a simple number, right? So now let's do this. Let's run this in our code and let's see. So now you guys understood what quadratic time complexity is. You can see it's n squared. You can see that this outer loop and inner loop runs on n squared, right? So now let's remove this. So I want to solve that simple example here. So on the first one, we say for I in range of 0 to x, which means that I is starting from this index 0 right down to the number of iterations in the first place, which is 4. Now for the inner loop, we have for O in range of 0 to x, right? Now, I will apply a conditional E because I'm trying to solve something here. I will make sure that it won't go out of index, right? So now, if n, right, if n of O is less than n of O plus 1. So let me explain it here. Remember that the first index starts with index 0. And let me just put uh, the first index here is index 0, right? So the second one is index 1, then the third is index 2, right? So now what we're trying to do is that if the value in index 0, look at it here, after we have looped through the first loop and looped through the inner loop, right? So if the first index, which is 3, let me use the number we use there, which let me use the number we use here. It's the PowerPoint slide. We have 3, 1, 2, right? So I'll have my 3, 1, and then 2. So if the value in index 0 is greater than, let me use greater than, is greater than the value in index 0 plus 1. So index 0 plus 1 is this, because if you have 0 here and 0 is starting from index O plus 1, sorry, and O is starting at 0, right? Starting from 0, sorry. So it now be 0 plus 1, which will give us this 1 here, right? So it means that if 3 is greater than 1, since 3 is greater than 1, so what we'll do is to swap. So will now be n of O right, comma n of o plus 1. So we swap n of o plus 1, n of o. So it means that n of o will take the value in n of o plus 1. Then n of o plus 1 will take the value, that is, you take the value in n of o, right? So you can see we have this, we swap them. So that is how it works, right? So that is how it keeps on going until it gets sorted. But now there's a problem here in this code, right? If we say this, and then let me make you guys understand how programming works, right? Remember, okay, the first one is o, right? N of o, which is 3, and the second one is n of o plus 1, right? So and the first iteration, right, 3 comes here and 1 comes here. Now, on the second iteration, right, O becomes 1, right? Then we now have O plus 1, which will give us 1 plus 1, which will give us 2. So it's now comparing this index 1 and index 2, which will now be is 2, is, sorry, this one is 3 greater than 2. Now, if 3 is greater than 2, it swaps, right? Now, because we didn't tell the computer to stop, right, to stop the iteration, the computer will still do another O plus 1. And if you check our array here, there is no other O plus 1. So it will give us out of index, right? So this code naturally will return an error because we didn't actually control this, right? We didn't actually control this to go out of range, right? So if I run this, definitely it will give you an error. Can say least index out of range because of the O plus 1. So it's like it's want to compare another indexes which doesn't exist. So to be able to limit that, what you do is to put -1 here, right? So -1. So now doing the count of this operation here on the second loop here, instead of looping 3 times, right? Instead of iterating 3 times, it will now iterate 2 times, right? So what I mean, now iterate 2 times. So it means that on the first loop, that is, first loop it compares 3 and 1, the second compares this and it stops. Right, but if you didn't put -1, it will run 3 times. So if I run this now, it will give me no error. But I haven't print out my result here. So I'll print my n. So automatically this will be sorted, right? You can see it has been sorted 1, 2, 3. So now we need to understand the process how these get sorted, right? So if you want to understand the process, if you are confused, you can put a print within this function here to see how these things are sorted, right? So I can do this. I can say okay, print, right? Print f. Then I can say value value dix, which is value of the value here, right, was swapped with value this that's located in index this was swapped with the value n o plus 1 located in index located in index of o plus 1. So now if you run this, so now this is how it works, right? So you can see it here, value 1 located in index 0, value 1 located in index 0 was swapped with the value 3, right, located in index 1. So this is n of 0. Okay, sorry, I made a mistake. It's supposed to be this o, not 0. So I was looking for where the error is coming from. So now value 1 located in index value 1 located in index 0 was swapped with the value 3 located in index 1. So value 1 was not located in index 0 at first place. So let's move this print, right? Let's put it within here. So if this located in this, so this one at first is 3, right? So let's do this. Yeah, this is correct. This is the correct one. So value 3 located in index 0, there you can see value 3 was located in index 0, was swapped with the value 1 located in index 1. You can see, so that means it swapped it. That's why we are swapped with, and the next line we swap them, right? So the second one, value 3 located in index 1. So you can see value 3 now is now in index 1, right? Remember in the initial stage, value 3 was index 3 is 0. So value 3 located in index 1 was swapped with the value index 2 located in index 2. At the end, we have this sorted, which is 1, 2, 3, 4. So now what if we have another number here, which is 0, right? So if I run this, you can see value 3 located in index 0 was swapped with the value 1. You can see how it's compared to adjacency. That's why I printed this, so you see how the steps it takes to do this. So you can see value 3 was swapped. So value 3 located in index 1 was swapped with the value 2 located in index 2. You can see now swap again, not just value 3 comes in here on the second iteration and then it swaps. Then value 3 located in index 2 was swapped with the value 0 located in index 3, right? You can see how it works, right? So 3 comes to this place, right? So it goes again to the first one here, which is this one. So value 2 located in index 1 was swapped with the value 0 located in index 2, right? Then value 1 located in index 0 was swapped with the value 0 located in index 1, right? You can see how it does that and it gets it sorted 0, 1, 2, 3, right? So this is how the bubble sort works. It's very simple, right? So this is nested loop. If you understand how the outer loop and the inner loop works, right, you can actually solve any problem that has to do with nested loop. So on other videos, we're going to solve so many problems on nested loops, right? So thank you and God bless you.